Okay, welcome back. Now we are going to start with this lecture chapter 2 on the convolution. And now I'm going to share the slides on the convolution. Anybody can see?
Yes, sir.
Yes, sir.
Yes, sir.
So this slide is actually a very short one. Not that really short actually. It's about 30 pages or so. And we cover on the convolution. And I think I did forward YouTube videos in MS Team. So I hope that you can see, you can watch that video. Actually, the video, the shortest one, is very easy to understand. Actually, the operation of the convolution in animation. So it animates how actually the convolution operation is done. So this is the introduction of convolution. Convolution is actually a mathematical operation on two functions. So basically that you have function x and you have a function h, right? And the operation between this x and h will produce the output, the third function of, we call it y. So how this operational function looks like, we'll see later. Okay. So in linear systems, convolution of one function, i.e., is used to describe the relationship between three signals of interest: the input signal x and the impulse response h of t, and the output signal of y of t. So you have a signal x of t, will convolve with h of t and produce y of t. This is the mathematical expression of a convolution. And the output for any input signal can be obtained from an integration between the input signals and the system's response. So it can be written as y of t is equal to x of t convolved with h of t is equal to the integration of minus infinity to infinity of x of tau h of t minus tau d tau. So that asterisk indicates a convolution operation. The convolution operation is basically, it's like you can imagine two signals. One is stationary and another one is actually moving towards that stationary signal, and it start to overlapping. And if we start to overlap, then after that, we'll move on. So basically that the moving signal is actually a window signal. So you can see that in the video that I posted in the link in the MS Team. So it's actually a moving window. That is the convolution. What is the properties of convolution? So it has three properties. It's commutative property, associative property, and distributive property. What is a commutative property? It's a symmetrical property where x of t convolved with h of t is actually equal to h of t convolved with x of t. So it's interchangeable. Right? So x of t going into the systems of h of t will produce y of t. And it's the same thing as also you reverse the h and x. So h of t, combo of which h of t will produce y of t. So it's commutative property. Right? That is the first one. The second one is associative. It's a free order. You can order in any way you want. If you have three functions, x of t, h1 of t, and h2 of t, you can have x of t convolve with h of t first, then convolve with h2 of t, or you can do h1 of t convolve with h2 of t first, then x of t convolve with the result of that. Or you can switch h2 of t and h1 of t, the order. So that is the associative properties of the convolution. So you have x of t convolve with h of t, then convolve with h2 of t, produce y of t. Or you can have x of t convolve with h2 of t first, then convolve with h1 of t, produce the y of t. Or you can convolve first h1 and h2, then after that you convolve h of t with the h1, the result of the convolution of h1 and h2 to produce the y of t. That is the associative properties. And the third one is distributive. The distributive properties indicates that, says that h of t, x of t convolve with h1 of t plus x of t convolve with h2 of t can be written as h of t, x of t convolve with, in the bracket, h1 of t plus h2 of t. Okay? So by diagrams, it can show, as shown below, basically that x of t can simultaneously convolve in parallel with h1 of t and h2 of t. Then you go into a summer to have a result of y of t. Or you can have h1 of t add with h2 of t first, then x of t convolve with that to produce y of t. Okay. So that is the three properties of the convolution: distributive, associative, and distributive. Okay. From these properties later that we're going to use in our analysis of the systems. In terms of the graphical convolution, right? So this is how you do the convolution. First step is the express each function in terms of a dummy variable tau. Any questions so far in terms of the properties of convolution? Clear?
Clear, sir.
Okay.
Yes, sir.
I think you have studied this in your math, right? In the differential equation, or you have not taken differential equation yet? Dah ambil belum?
Dah, sir. Differential equation SEM 2, sir.
SEM 2, dah ambil dah?
Dah ambil, sir. Dah ambil, sir, tapi tu lah.
Sedang ambil ke dah ambil? Dah ambil.
Dah ambil, sir. Dah.
Basically, you dah tahu dah pasal convolution
Sudah.
Belum,
Video
sir.
yang saya bagi.
Okay.
Tahu, sir.
So the first step is express this function in terms of a dummy variable t, variable tau, then reflect one of the functions. So basically that you inverse. So h of tau is reflect to be h of minus tau. Then third, you add a time offset t, which allows h of t minus tau to slide along the tau axis. So this one that I say that the moving window study. So H is the moving window. Okay. Then start t at minus infinity and slide it all the way to t equal to plus infinity. So wherever the two functions interact, find the integration of that of their product. So you multiply. Then the resulting waveform is the convolution of the function f and h. Okay. So anybody has watched that video? No. Belum lagi.
No, sir.
Belum lagi.
Tak tengok lagi.
Tak tengok lagi. After this you
Tak
watch.
lagi, sir.
After this you watch the video, and ataupun let me see. Most probably that I can try to show the video. Okay, maybe I can try to show the video. Wait. Which one? Let me see first. Not this one. Wait, let me see. Maybe this one. Okay. Okay. Apa tu?
Hai, bunyi apa ni?
Music siapa tu?
Abang jago.
Siapa buka TikTok tu?
Abang jago tu dah lain.
Okay, kejap.
Buka TikTok tu, sir.
Kenapa tu? Kenapa tu?
Okay. Sekejap saya cari mana video tadi. You can see the video? Animation of convolution of two signals. Nampak tak?
Tak nampak
Oh,
sir.
sir, tak ada sir. Tak ada sir.
Tak ada. Apa yang you nampak?
Tak nampak apa pun sir.
Tak nampak apa?
Apa-apa.
Okay. Sekejap. Saya buat macam ni lah. Saya share the
Link.
saya share the desktop window lah.
Baik, sir.
Entire-
Baik, sir.
So saya share the entire screen. Share. Nampak tak? Nampak?
Nampak ke? Nampak ke?
Animation
Nampak,
of convolution.
Nampak.
You punya screen nampak?
Nampak. Nampak ke?
Nampak.
Nampak.
Okay. So this is what I say. Okay, tengok
Tu dia.
Ni belum lagi.
Belum lagi tu dia lah.
Okay, let's say that you
Oh.
have these two signals, f of t and g of t. So now that is the convolution of two signals. You see the animation? How one window is static and the other one is moving. So the g of t is really moving. F of t is static. And the bottom graph is actually the resultant of that convolution. That is actually the integration of minus infinity to infinity of f of t and g of t minus tau and f of tau, d tau. Okay, nampak? That is actually the operation of convolution. Then all zero after that. So that is the result of the convolution of a two signal. So result of the convolution of a function of t. Okay. Now I go back to the okay. Now I share the slide. Okay, now we continue with our slides. So you see the slides?
Nampak
Graphical
ke?
convolution.
Yes, sir.
Huh?
Nampak,
Nampak?
nampak.
Boleh tinggal.
Okay. So basically that what I showed just now is actually all these 5 steps, which is on the operation of the convolution. So express the function in terms of tau, reflect one function, h of tau, to be h of minus tau. Then you add the time offset t, which allows h of t minus tau to slide along the tau axis. So in the video just now, instead of h, we call it g. So the g t minus tau is actually moving. So it's starting from t minus infinity until to t plus infinity. And the resulting waveform shows at the bottom in the video just now. So that is the animation for this graphical convolution. So let's say we take an example. X of be the input signal for the LTI system with the impulse response h of t, where x of t is equal to e to the minus at ut. Ut is actually a unit step.
Unit
Step
step.
function, basis function just now, where a is greater than 0 and h of t is equal to ut. Determine the output signal y of t for the systems. See that first, this is x of t, e to the minus at ut. So basically that it starts from 0. Before 0 is t minus is actually 0. So this curve that you have. Okay. Then what you do is that express each function in terms of a dummy variable tau. So you convert into from x of t to be x of tau. So e minus a tau u tau. So you have this. And h of t, which is a step function, unit step function, you convert into h of tau. So you have this. That's step 1. Step 2. First, h of tau. So reflect the function of h of tau to be h to minus tau. So now you flip and the y-axis. So it becomes like this. Second step. Third step, you shift at time offset t. So it becomes t minus tau. So you shift. So if you look at just now, it start to it actually change here at 0, but now you shift by t. So now it start from here instead of here. Then step 4, what do? You start sliding t at minus infinity all the way up to the plus infinity. So now you start sliding from here, move towards that. So basically, you are implementing the y of t is equal to x of t convolved with h of t, which integration from minus infinity x of tau h of t minus tau d tau. Okay. So you do this. So you start moving. Okay. Sliding the ht minus tau window over the x of tau function. Where is what do you call it, overlap, you multiply. So basically this x of t is basically e to the minus a tau, and h of tau is 1 from 0 to t. Okay. So you get this 1 over a times 1 minus a tau. So the resulting waveform is this, the result of the convolution of the signal. So y is equal to 1 over a times 1 minus e to the minus a tau u minus at ut. So this is the result of the convolution. Second example. Given two following signals, r of t is equal to ut minus 1, and a second signal s of t is equal to 2ut t plus 2 minus 2ut t minus 2. Signal y is the product of convolution between these two signals, and you need to plot. Okay, first one. The top one is s of t. This is the function of s of t. Actually, if you plot this s of t here, okay, you plot this, you have this. Do you know how to plot this? This? You know this? Basically,
Tahu ke?
tak tahu? Tahu tak?
Saya lupa sikit.
Lupa? Okay. This one is basically that, let's say this t, say this, okay. You have 2u of t, 2u of t plus 2. So plus 2 is lebih kurang here lah, minus 2 here. And here is 2. Okay. This function is u is basically a unit, is a unit step. So the amplitude is 2. Okay. So t at minus 2 is 0. Minus 2 plus 0. So u of 0 is actually 1. 1 times 1 is 2. So you have the first function is this. The second function, then you minus with the second function. The second function is actually t minus 2 is actually here, up to here. But over here is cancelled out because it's a minus. So this one is 0 here. So the resultant function is actually this. Nampak? Clear? So this function
Nampak
is
sir.
actually, this function is at minus 2. This one is actually at 2. So when you combine these two, so you get this.
Oh.
Okay? Clear? So
Ya sir.
so this one pula is like this. U of t is this function. Okay? And t minus 1 is actually here. Let's say 1 here, 1 got to 1. And this one actually, the function is here, like that. So this one might, this actually, because of minus sign, so this one is cancelled out. Because actually like this. If I want to draw that minus, actually, if I want to write u of t plus minus u of that, then basically that I have to draw like this lah. This one and this one. So basically this one is cancelled out. So I have this term. So 0, 1 with a 1 here. This one is 2 minus 2, 2. So that's why we have this minus 2 and 2 with an amplitude of 2. And this r of t, especially from 0, 1 with amplitude of 1. Okay? So this, I just draw already. This because of that. Okay? So then you replace with the dummy variable t to tau. So the shape is still the same. You just step 1 is just you replace t with tau. That is step 1. Step 2, flip r of t. So from here, r of tau, you flip. So becomes like this. So basically, this one, you flip with respect to this axis. So if you flip, just like this lah. There. Yeah. So jadilah sini. This. It's just a flipping. Then you add the time offset t. So basically, this you offset by t. So this waveform shifted to the left by t. Yeah. So this point becomes t minus 1 because this width is 1. There is a second step. Third step, you start to convolve. So this is the r t minus tau, and this is the s of tau. So you start to slide this from minus infinity to infinity. So this is minus infinity here. And here is the infinity. Right? Okay. Now, so this, when you start to overlap, then this expression, the convolution expression, then you have the from where? From minus 2 to t of 2 as tau is 2 and r t minus tau is 1. So this is actually, this is 2 for s of tau and this 1 for the r t minus tau. You get that. So when you do the integration, so you have 2 tau minus 2 to t. So you get 2t plus 2. Then you draw. So this is basically still continue just now. So still step 4. So at this point, t minus 1 to t, or this function is still the same. So you get 2 until it reach the intersection here. First step tadi at this. This second step is inside of this box. And third, after this, we do this at the end here. So you have to do 3 piecewise integration. So you get this. You do the calculus. This one, I think I don't have to go through with you. Then the third one is basically when it pass. And the fourth one is when there is no overlapping anymore, then you get 0. Right? So therefore, the resulting waveform is 0, is between t less than minus 2 and t greater than 3. This actually you get from this. This is actually when t less than minus 2, this at t less than minus 2. So you get this 0, and t greater than 3 comes from here. This one, this condition, okay. And 2t plus 2, this one comes from this. Actually, this condition, okay. And this condition comes from here. So what we do is basically a piecewise integration. And the last one comes from here, this condition. So you have this, the result of the convolution. And when you plot, so you get this shape. Right? 0 when t is less than minus 2, and also 0 when t is greater than 3, and 2t, 2 times t plus 2 in between minus 2 to minus 1 here. So you get this. Then it's a constant 2 from minus 1 to 2. Then 2 times t minus t for t between 2 and 3. So you get this. So this is actually the convolution of that signal, of those two signals. Any question? If not, this is the summary, the basic summary of the graphical convolution. Step 1, you express the function in tau. Step 1, basically, you just change the t to tau. Step 2, you do the reversal. From tau, reverse to minus tau. Step 3, you add the time shift. So t minus, you add the t minus tau. This. So jadi h t minus tau. Okay. Step 4, you start to shift from minus infinity to plus infinity. And you have to do this thing, you have to do the integration piecewise, depending on your function. Then after that, you plot. So these are the 5 steps in graphical convolution. Any question?
No, sir.
So if you don't have any question, therefore, that is the end of the chapter on the convolution. So what time is it now? 1:07. So you have any other class after this?
At 2
2 p.m. sir.
2 p.m. So okay. So if you don't have any question, we can stop here so that you can have lunch and prepare for the next lecture.
All right, sir. Thank you,
Yes,
sir.
sir.
If you have not watched the video, the 3 or 4 videos that I posted, the link, then you can you can start watch that when you have free time. Okay.
Alright,
So,
I will. Sir.
and I'm going to stop the recording here. So see you on Thursday. Okay. From what time? Thursday 9.
Yes.
Okay, so we see you at 9 o'clock on Thursday. So I stop the recording.